If you can dream it, CET can draw it. My name is Jennifer Burke, and I'm going to be talking about how to create a 3D graphic from scratch. Little about me is I'm a senior CAD Training Specialist at KI in Green Bay, Wisconsin. Been using CET for about 9 years. 10 years married to Justin. We have a dog named Robin, and we currently have an addition in process, which is looking to be about done at the end of this year. Super fun process, and also been using CET for some design 3Ds. Me and CET, been using it since about 2012. I was working with our architectural wall team at that time to specify walls. Became an AutoCAD trainer in about 2014, so I took a hiatus of using CET. At that time, we had only used AutoCAD. 2019 came and we piloted our first KI systems product in CET, and that was very successful. So we started full development right at the start of COVID in 2020. Been part of KI's QA team since then. Launched all of KI product at the end of 2023. And then I did get to train all the designers that work for KI, along with our affiliates for dealerships that sell KI furniture. I spoke at the CET conference last fall in Arizona, and the last few months have been working very specifically with the programmers on updating our extension to the new UI format. We just switched over one of our lounge menus to the new UI, new buttons, to kind of doing some housekeeping at that same time. So that has been a super fun process, and I can't wait to see what it looks like after everything is done. All right, the goal of this presentation is to make you feel more confident producing 3D graphics from scratch using the tools within the menu. Little pop quiz. Using 3D tools will automatically populate a part number in the calculations. That is false. Using 3D tools will automatically unite multiple 3Ds into one object. That is also false. Last question. To unite multiple 3Ds together, they need to be made editable first. And that is a true statement. All right, our first concept, we're going to be creating a table with Our first concept is we're going to be creating a table with mail slots. All right, take a look at the finished rendering. We need to do a 24 deep by 72 inch wide, 36 high, and it also has mail slots that are 6 inches deep, 6 inches high, and 3 inches wide, and all laminate. We're going to first start by using the 3D rectangle tool in CET to create a rectangle of the upright. It's 1.25 wide along with 34.75 thick and 24 inches deep. We'll hop on over to CET and take a look at our 3D drawing tools. So we'll grab that tool and make our upright at 1.25 thick, 24 inches deep. At this point, we are going to create an extrusion going up, also called thickness in CET. So that we're actually going to make 34.75 inches thick. Pardon me there, 34.75. What that will allow you to do is be the total height of the upright, and we are going to make a work surface that is 1.25 inches thick for a total height of 36 inches high. You can now use the rectangle tool to create that top of 72 inches wide, and you can actually just snap on over to the depth of that. Select the 3D and choose the thickness to be 1.25. You can fill it up as long as we have it snapped to that top of that upright. At this time, you can copy that other upright over by selecting it and hitting the letter A. Drag it on over and type in 70.75. That'll get you right at the end of that work surface. Lots of math. The next step is to add that facade where the mail slots will be cut out. So we'll add that by using the rectangle tool again. Snap it on the inside of that upright, drag it over to the other upright, and then we'll go in about 7.25. And the reason being is the depth of the mail slots is 6 inches, and I want to have a back panel shown so that way you don't have a hole all the way through. So once that's created, we'll grab that shape, and here we'll have to give it some thickness and make sure the elevation is correct. So let's check that elevation. Let's move it down to 27.5. And then what happens when I make that thickness, I'm gonna do 7.25 again, so that way it still has that extra inch or so that way when we do the mail slots, there'll be room to have that edge banding around it. So we'll take a look, and it looks perfect. To create the mail slots, we are going to use the 3D drawing tool again, 3D rectangle. I'm gonna draw the mail slot itself off to the side. So the mail slot is 3 inches wide by 6 inches deep. So once we get that drawn, we will give it some thickness, and we'll do that also at 6 inches high. And once we have that actual slot created, we're going to move it to the middle of the facade, but also ensure it's at the correct elevation. So let's actually do that elevation at 28.75. And we'll move it into the center, and you'll see that what it did is by doing it at that 28.75, I now have that 1 inch banding at the bottom, and then there's a 1 inch thickness of the work surface on top of it. So that was the whole method to the madness of doing that 7.25 thick facade and the depth of it. So you can see how when we're going to be subtracting this mail slot. Once you have one in, we're just going to simply copy it over. So let's copy it over 4 inches, and we're going to create 5 of these. So we'll do 2 on that side, click off, click on that one again, hit the letter A, grab this over 4 inches, so it's about an inch in between each 2, each 3, each 4, each 5. All right, once they are created, we are going to subtract the smaller one from the bigger one. So to subtract, you're actually going to select the smaller one first. And then you hold down your shift key and select the outside. So once you had held down the control key, you'll see that this box pops up, and we're going to click on subtract. You're going to continue doing this 4 more times. Select the smaller one first, hold the control key down, and select the outside so that both of them are selected. And then you're going to hit the word subtract. So you're going to keep doing this. So we'll grab the smaller one, grab the outside, and click subtract. Small, bigger, subtract. We've got one more. And subtract. So we'll verify that all 5 holes are empty. We'll take a look. You can see the back of the laminate, the sides, and the top. To finish this one up, we'll talk about applying finishes. You can either create a finish or locate one in the Material Explorer and apply. So we'll get one of these applied to all of the faces, edges, the uprights, etc. And let's take a look at how the grain direction is going. So something to consider is ensuring that the grain direction is represented correctly going left to right, for example. So this front facade and these edges, in my history with furniture, I have seen it going left to right on the widest part of the laminate. So to refresh everyone's memory, we're going to grab the previous material that would be created, whether it's already created from another manufacturer or one that you've created yourself. You can edit it by going into the Material Lab. And usually it's easy enough to just rotate it. So that's one way. So we'll switch that 90 to a 0 and rotate it, and then reapply. you may have to adjust the width and the height. So for example, this 25 and 51 could get flipped around to change the scaling. Sometimes the grain direction doesn't know the correct scale. So let's just take a look and see what happened. So it looks pretty good. So we'll apply that to the edges as well. Awesome. All right, the last step I'd like to talk about is uniting all of these 3Ds into one. So currently, if I was going to just grab this work surface, it would be detached from the main event there. So what I'm going to do is we're actually going to use Edit Graphics to make this entire unit editable. And once it's all editable, we'll be able to window the entire unit and unite it into one object. So once you make everything editable, grab all of the uprights, the facade, that sort of thing, I would like to identify a bug that CET has currently. So this facade, take a look at how the material is now applied. There is going vertical, and we've tried using the material lab to create a different material going in a different direction, a different scale. There is also a fun little auto UV that you could do by clicking on the actual object and clicking on mesh dialog. There's this auto UV pick. None of these options seem to be helping. By doing that, it kind of made it a little worse. So we know that that is a bug that CET will hopefully fix. To avoid that is you could not use the subtract. So the issue with that is having that solid and having those additional solids subtracting from the main event there. You could just use a bunch of different rectangles to create your slots, and then the grain direction will go correctly, apply correctly I should say. Or maybe depending on the type of finish, maybe you're just going to be doing a white or a different solid, that sort of thing. So we'll just kind of grab one of these right now and just to make it look correct. So different things that you could do to problem solve. Once everything is editable, however, then you can select everything, and we'll go ahead and unite it by using Edit Graphics. You can just do one of these new snappers. And then once everything is connected, you can move it around all grouped together, and you could right click potentially, depending on the manufacturer, and add your information so it pulls in the bill of materials. The next 3D that we are going to create from scratch is a triangular power tower. The concept of this one is to create a laminate tower with a perforated steel on each side. The overall width is 36.5 by 32 deep and 32 high. The surface is 36.5 all around. The base itself is 26 by 26 by 26, and it'll all be laminate except for that perforated steel. A basic overview before jumping back into CET is we're going to create the triangle base. So we're going to draw help lines 26 inches long at a 120-inch angle. Another option would be if you had a manufacturer's drawing from the engineer, you could trace over that as well. Once everything is drawn at that 26, we're going to create a gap, a 1 inch all around, because we have to create a little chamfer, a little radius on each side. So let's head back into CET to demonstrate this. All right, over in CET, I already have my triangle help lines drawn, and I already cut them back 1 inch so that we'll have this gap so we can create a little arc at each corner. So I had used these help lines along the top and just drew my triangle. We are now going to trace over that triangle with a 3D custom shape. So go ahead and grab this third icon, snap to that first line, snap to the second one, and then what we want to do is we don't want to create a line, we want to create an arc. So in your quick properties, you're going to click on arc, and then this one's pretty easy. We're just going to snap it to that next line. So we'll switch back over to line, and all we're doing is simply tracing our help lines. And this will need to be an arc. So from here, we actually have to click on the start tangent, and we want to use 120 for this one. And then we'll go ahead and keep drawing a line. And then last but not least, this one starts tangent is 240. So we'll switch it back to arc, change the start tangent to 240, and then click to place. We'll take a look in 3D, and from here we're going to actually give it a thickness. So we'll click on that 3D custom shape. We're going to switch the elevation back to 0. The reason it went up a little bit is those help lines, so just drop that back down to 0. And we're creating a tower base, and from our stats, it's 26 inches high. So we'll just go ahead and add some thickness to that. All right, our next task is to create holes on all 3 sides so that perforated metal that we'll be creating will be able to be aligned with these holes. What we're going to do is draw help lines that are 26 inches triangular, which is the overall size of the actual unit. We're going to cut them back to be 24 on each side, so we have that gap. What that gap is representing this time is the edge banding around the hole. So we kind of think of it like a picture frame. We still want to have a frame around that hole, and then we still want to just have that negative space of the 24 inches. So you can certainly start by drawing the 26-inch help lines, then drawing 24, and replacing the 26. That is what I did. Now we're going to just simply trace over that help line by just only using the straight. So we're going to not use the curve this time. So we'll trace over this, and we're going to cut back here, trace, cut over, come down and cut back. So what that looks like in 3D is another triangle. So this time we want to also create that picture frame. So let's do a 2-inch above the floor as the elevation, so you'll have your picture frame banding at the bottom. Same thing on the top. So we have a total of 26 inches high. Let's do this one at 22. So we're going to combine these, and we're going to use that subtract. So a couple ways you could do that. You can just simply move these. So we'll go ahead and move that one right on top of that. Don't grab your dimension. All right, once that's snapped, you'll kind of see how there's the corners there. So we're going to use our subtract tool again. I'm going to grab the smaller one, hold down the control key. Sometimes it's a little hard to grab that smaller one. There we go. So smaller first, then hold down the control key to grab that larger one. We're simply going to use that subtract. So we created another triangle that sat inside the previous triangle, and then we subtracted that space, like so. You can simply delete your help lines as needed. Our next task is to create that perforated steel grate that is going to go on all 3 sides. So back over in CET, we're actually going to draw this perforated grate as if it were laying down on the floor. So to fit into that hole and just be a slightly bigger than that hole that we just created, we're going to do 23.5 inches wide by 22.5 down. So once that perforated steel is created, let's get a little bit of a thickness. So we'll make it, what, 0.25 sounds good. Next, we're going to head over to 2D, and we're going to create a perforated hole circle. There could be multiple ways to do this, but I'm going to draw a 3D circle with a radius of 0.25. And then I'm actually going to give it a thickness so it protrudes through that perforated steel plate. So let's actually just do that as a 1 inch. So it should look like this. We're then going to eyeball it. Again, there could be multiple ways to do this, but I'm going to move that square over that top left corner of the circle, so it kind of looks like that. And we're actually going to use the replicate tool. So select your work surface, select your circle, and head over to the object pull-down menu and click on replicate. This tool is pretty powerful. What we're going to use it for is copying that circle over to the right 30 times, and then we're going to copy it down 29. And there's going to be a spacing of 0.75. What I'd like to instill in all of you is to just play around with these numbers. You may not know exactly the spacing that you need, but you can simply hit apply. CET will calculate and kind of give you a preview. You can always undo. So this looks good to me. Once it's applied, if you'd feel like you want to kind of center that square a little bit more, just click on it. You can use your arrows or hold down Shift and move it. What I'd like to show you next is the Create Holes tool. So we'll click on the rectangle, and we're going to actually just click on this Create Holes. So what's going to happen is all of those little circles are going to extrude through the main rectangle. So once that happens, you'll take a look and see you have all of those holes. The next topic is we need to rotate this up so that it is vertical. Right now it is laying down on the ground. So the normal rotate only lets you rotate around that axis. However, if you were to make your graphic editable, it'll allow you to rotate around the Z-axis or any other plane. So once you make this editable, you want to hit Make Editable and ensure a couple things. You want to make sure that you have this apply to group, and you want to make sure that you're in group select and not single select by clicking on the keyboard S to toggle between the two. You want to make sure that it highlights in blue so that it's going to make every little part editable. So let it do its thing. Once it catches up with us, we're going to select everything again. I always like to do this just to make sure that everything is literally selected there. So whether it's in 2D or 3D. And then there's this awesome little rotate tool. So we're going to grab that. And we actually want to be on the axis of X. Might have to click on it and click off of it a couple times while it catches up. So creating those holes definitely creates a large file. So that is just definitely one way to do it. You definitely could also use a material in the Material Explorer, play around with the opacity and creating meshes and or circles that way. So we're going to get on the X plane and we're going to click once, and then we want to go to initiate the command, and then we want to go from 90, and then we want to go to rotate to 90. So we'll grab that and click. So it's just going to kind of rotate in the direction that we need to. It's going to end up under the floor, but we're going to be able to change the elevation, and we're going to marry these together. We are going to copy it 2 more times and rotate as well. One thing I do want to note is if you check out your 2D, you're going to see all these little extrusions left behind. Think of those as a placeholder to create those circles, but we do not need those circles anymore. So I have found the easiest way is to just grab your actual plate itself. You can certainly detach it, and then we're just going to kind of move it away from all of those circles, and then grab all of these circles and then delete them. So we can take a look at while we're doing that. I deleted the wrong thing, so let's head on back. We'll undo a few times here. So what I wanted to do, and I'm glad that happened because it happens to me pretty much every single time I'm using that Edit Graphics tool. So I want to use the Mesh dialog, and I want to select that outside. But I'd only selected one part of that rectangle face, so only part of it detached. So you want to make sure that you're grabbing all of those meshes that entail that entire object. So then we're going to detach, and then we're going to move that away from all those other little guys. So now when we delete them, we're only deleting those holes, and then we're still left with the actual plate itself. To move these together, one option would be to select both objects and use the tools and align and distribute. And on the far right-hand side is this align to top elevation. What that will do is it'll at least get it to the top of that tower. And a couple other ways you can accomplish moving this. Like anything, you can click in the 2D view, And you could manually move this over, get this kind of centered like that, get this moved in just a little bit. We want to make sure we can still see the edge of the frame protruding out, so like that, for example. And then check your 2D and then use that page down to get it kind of centered. You can also hold the shift key and page up or down to get it in smaller increments. Everything looks great. We can now copy this material over. So in 2D, we can hit the letter A to copy. We can rotate this 120 and then manually move this as well. Copy again. This time we're going to rotate 240 and manually move this as well. Move that into place. Take a look at your 3D, ensure everything looks great. The last step is to create the work surface, apply finishes, and unite everything. So for example, we're going to do another triangle, but that is 36.5 inches triangular. So we'll do the same help lines by drawing the 36.5, and then we're going to cut them back so that it's 35.5 total, so that we have those circles on the edges there. And we'll follow along with the line tool, the arc tool, and the additional lines to connect all of them. I already have the top shape drawn with the help lines, so all we need to do is trace it. We'll go ahead and grab that 3D custom shape, and we'll ensure that we're drawing a line first, and then an arc. Snap it to that first one. Draw another line, head back up here, grab the arc, change the start tangent to 120, grab the next line, down here, arc and tangent is 240. All right, so what we'll do is we'll take this work surface, start elevation will be 26, so that's on top of the storage tower part. Do 1.25 for the thickness of the work surface, and then we can align and distribute these. We can certainly just eyeball it, so we'll hold down our shift key, get it so it's mostly centered, is one option. You could draw another help line from that tower down, and we could move this from the middle to the middle. Awesome. So when everything is done, we're going to want to unite this as well. So we'll have to make everything editable. So make the work surface editable. All of the parts should all be editable already. And then the goal is to be able to unite everything. So we'll reselect it all, grab Unite, and do a new snapper and click OK. Ensure everything all connected, and it looks like it has. Then you can finish by applying materials and adding a part number. Let's make all the sheets green. Now, if you want to apply it just to the circles, but I would like to apply it to all of it. So we're going to click on the tab key and tab down so that all of it is selected. It's the easiest way to do that, because then if you need to click on another material, you can do the outside and all of the edges. That way all of those holes are selected. Once you have all the materials on there, simply right-click and apply part information per the manufacturer's process. I'd like to thank all of you for watching. If you need any help with anything, please contact me at jennifer.burke@ki.com. Thank you.